All right, so we have a sample problem here from the Calc AB free response question. No calculator allowed, unfortunately, on this part of the exam, although the calculator probably wouldn't help. So we have the graph of a differentiable function f is shown above for -3 is less than or equal to x is less than or equal to 3. The graph of f has horizontal tangent lines at x equals -1, x equals 1, and x equals 2. The areas of region A, B, C, and D are 5, 4, 5, and 3, respectively. Let g be the antiderivative of f such that g of 3 equals 7. All right. So part A is asking us to find all the values of x on the open interval -3 is less than x is less than 3, for which the function g has a relative maximum. Justify your answer. So we know that g is the antiderivative of f. What does that mean? That means that g prime is equal to f. So if I were looking at a graph of g and I were trying to find the relative maximum, I'm going to go ahead and just draw a small example. So let's say that this is a graph of g and I have a relative maximum right here. What's happening with g prime? G prime is going from positive on the left-hand side where we're increasing to 0 to negative on the right-hand side where we are decreasing. So I'm increasing, go to 0, decreasing. Positive, go to 0, negative derivative. All right, where is that happening in g prime? Because remember, f is equal to g prime. Where are we going from positive to 0 to negative? That's only happening in one place, which is right here. We go from positive to 0 to negative for our g prime, or for our derivative of g. Let's go ahead and put that into words. So g has a relative maximum at x equals -2, since g prime equals f, and f goes from positive to negative at x equals -2. That is our only relative maximum. Part B, on what open intervals contained in -3 is less than x is less than 3 is the graph of g concave up. I'm going to go ahead and draw a graph of g again. And let's say that we're looking at a part where we're concave up, opening upwards. What's happening to our g prime? G prime is increasing. G prime is increasing as we are concave up. So where do we see on our G prime graph that we are increasing? That is happening at -1 to +1. And then it's happening again from 2 to 3, that our derivative G prime is increasing. So for part B, G is concave up on the open intervals from -1 to +1. So G is concave up for -1 is less than x is less than +1. And then again on that open interval from 2 to 3. So also for 2 is less than x is less than 3. Since G prime equals f is increasing on those intervals. That's part 1 and part 2, or part A and part B. Part C says, find the value of the limit as x approaches 0 of g of x plus 1 over 2x, or state that it does not exist. So I'm going to go ahead and look at the numerator first and then the denominator. So let's start with just g of x. So we first want to state that g is continuous at x equals 0. And then we can take our limit as g of x approaches, take our limit of x approaches 0 of g of x, which is just going to be g of 0. And then we don't actually have g of 0, but if we scroll to the top, they did give us g of 3. So I'm going to go ahead and work backwards a little bit here. G of 3 is equal to g of 0 plus that integral of our antiderivative from 0 to 3. Because remember, f of x is g prime of x, which means that g of 0 equals g of 3 minus that integral. G of 3, they told us was 7. And the integral from 0 to 3 of f of x is just our areas, c and d, because we're looking at that range of 0 to 3 for x values. C has an area of 5 and D has an area of 3 because they gave us that information. C and D were 5 and 3. So we're just going to subtract that 5 and 3. So we have 7 minus 5 plus 3, or 7 minus 8, which gives us -1. So if we wanted to evaluate the limit of our numerator given in C, we are looking at the limit as x approaches 0 of g of x plus 1. That's going to be -1 plus our +1, which gives us 0. What about our numerator? Our numerator was 2x, and the limit as x approaches 0 of 2x is going to be 2 times 0, which gives us 0. All right, so if we wanted to look at the limit of g of x plus 1 over the limit of 2x, we're going to get 0 over 0, which gives us an indeterminate form. All right, so I'm going to go ahead and state that it's indeterminate, but that doesn't mean we can't find the limit. It just means that we're going to have to turn to our handy dandy L'Hopital's rule. Okay, so since the limit as x approaches 0 of g of x plus 1 over 2x is indeterminate, we use L'Hopital. And that is how you pronounce it, folks, L'Hopital. Okay, that just means that if we have an indeterminate form, we are allowed to take the derivative of our numerator and denominator, and that is also going to be equal to our limit. Okay, so we have the limit as x approaches 0, g of x plus 1 over 2x. I'm going to take the derivative of my numerator. So that's going to get me g prime of x. And the derivative of my denominator is 2. Since g prime of x is f, that's going to be f of x over 2, which just gets me f of 0 over 2, which equals 0. Gonna go ahead and put a bold box around that. That's my final answer. And then part D, let h be the function defined by h of x equals 3f of 2x plus 1 plus 4 Find the value of the integral from -2 to 1 of h of x dx. Okay. I'm going to go ahead and try to write a tad bit smaller here so we can fit our work in. So this is the integral that we're dealing with, h of x dx. And they told us that h of x dx is the same thing as 3f of 2x plus 1 plus 4. Don't forget your dx. I'm going to go ahead and take that constant of 3 out.